enough time to dissipate. The next effect is that the slope can fail under undrained condition. If the water level in the reservoir remains at low levels and failure did not occur under undrained condition, seepage of groundwater would occur and additional seepage force could provoke failures. From these two pictures, we can notice rapid drawdown and ground seepage. During rapid drawdown, this draining water force is removed, just like this river. The high water level and the rapid drawdown to the low water level, and in the slope, soil or water. The water in the slope will result in the seepage force and will provoke the slope failure. Will increase the seepage force. And the ground, just like this, is the direction of seepage. Now when we designed the subgrade, we should calculate the stability, slope stability. And how to calculate? There are some parameters we should know. Commonly is 3 parameters. GAM 5C. GAM is the soil density, weight. Phi is the friction angle of soil. C is the coefficient of soil. But the subgrade is filled with different layers of soil. For certain or for subgrade, for example, with height, slope height is 10 meters. 10 meters. We will fill with different soils. But for different soils, we have different parameters, soil properties. So these 3 parameters are different. So we should divide selections in layers to make the parameters consistent. Just one layer has the same parameter. For high embankment, the direct consolidation quick shear test or triaxial consistent undrained shear test obtained or are used to determine the parameters of different soils. We can use direct consolidation quick shear test or triaxial consolidator undrained shear test. But for softer soil foundation, the parameters we should determine according to the direct quick shear test and triangle and consolidated undrained shear test. For softer soil, we should use unconsolidated. But for high failure, we should use consolidated soil. Value of slope. But for some subgrade, we have different slope ratio. We should use the compensated slope value as well as the approach expression of the connecting line between the top, just like this. Between the top and the toe of the slope. The line, connecting line. This is the and the one is the comprehensive slope value, just like this AB. And the toe and the top, the connecting line and the slope ratio, and the value of the slope. But for subgrade, we should consider the vehicle load. So, we should equivalent conversion of vehicle load use these formulas. From this formula, we can know that we can see this picture. We have two vehicles. We can use the two vehicle. What's name is, and the B is wheel base for rear wheel. The B. M is the central distance between rear wheels of two adjacent vehicles. Gam is soil specific weight, and B is transverse distribution width of load. Distribution width of load. We should calculate the equivalent conversion of vehicle load. Use this. We can use the H0. H0 is the equivalent vehicle load. It's just like this. And L is maximum vehicle base of front and rear wheels. It's commonly 12.8 meters. L and Q 550 kilonewton Newton. But for N dual lanes, N is 2, and the single lane N is 1, and we use this to calculate the transverse distribution width of load. It's like B is N B plus N minus 1 times M plus D. D commonly is 0.6 meters. So for two dual lanes, we can know this is N is 2. But for three lanes, N is 3. We can, according to the actual conditions, to determine the equivalent conversion, the H0. But we should consider different conditions. But for infinite slopes, just like for soil or coarse green soil, we can use the infinite. We can, according to the formula of infinite slopes, to calculate. Infinite slopes have dimensions that extended over great distances. The assumption of an infinite slope simplified stability calculations. Now consider clean, homogeneous, 'cause, homogeneous, 'cause, green soil of infinite slope. of S we can use for a single slide. For a single slice. Just like this. Forces on a slice of soil in an infinite slope. On the two sides of the slices, just left or right, there has XG and EG. And on the base of the slices, they have MG and TG, and the BJ is the width of the slice. Commonly, we can use the BJ is 1 meters. This is the assumed slip plane. From this, we can know that the factor of safety of the slope is defined as the ratio of the available shear strength of the soil to the minimum shear strength required to maintain stability. We can use this to calculate the factor of the safety. But for effective strength and total strength, we can use these. And these formulas individually to describe. So, firstly, we consider the slope without slippage and groundwater below the slip plane. Because the groundwater is below the slip plane, the effective strength is equal to the total strength. From statistics, we can know that NGI with and TJ use these formulas. This formula. Another from the definition of factor of safety from the ESA, we can get the Fs is times 5 and times half x. At the limit equation, we can know the factor of safety is equal to 1. Therefore, half x is to 5. The implication of equation 6 is that the maximum slope angle of a coarse grained soil cannot be exceeded by phi is the friction angle of coarse grained soil. So if the phi s is larger than the friction angle of coarse grained soil, it will occur the slope failure. Now, before we cannot consider groundwater, but we consider groundwater within the sliding mass and assume that slippage is parallel to the slope. The slippage force is this JS. Since slippage is parallel to the slope, I is sin phi s. From statistics, we can obtain or get the NJ and TJ. From the definition of factor of safety TSA, we get Fs. Factor of safety is equal to this. And commonly, at limit equation, Fs is equal to 1. Therefore, tan phi s is equal to this. Just the way like gamma to gamma section. For most soils, this is to half. So simply panel to the slope reduce the limiting slope of a clean, coarse grained soil by about 1/2. Just like this. Dry sand is to be dumped from a truck on the side of the roadway. The properties of the sand are 5 is 30, that is 17 kilonewton per square meters. And ground century is 17.5 millimeters Newton per square meters. Determine the maximum slope angle of the sand, the dry state, and the saturated state based on seepage, and saturated state if groundwater is present and seepage were to occur parallel to the slope. What is the safe slope in the dry state for factor of city of 1.25? How to calculate? Now, in the dry conditions, S is 30. The safety from this Fs is 1.25, and we can calculate that Fs is 24.8 degrees. And determine the maximum slope for the saturated condition. The value is not significantly affected by whether the soil is dry or wet. Therefore, Rs is 30. Determine the maximum slope for seepage parallel to the slope. According to this, we can know that alpha S is 14 degrees, and before is 24.8 degrees. So this is when we calculate the saturated condition is less than the dry state. Two-dimensional slope stability analysis. Slope stability can be analyzed using one or more of the following: the limit equilibrium method, limit analysis, and the finite difference method, and the finite element method. Limit equilibrium is often the method of choice, but the finite element method or the finite differences method is more flexible and general. So, commonly when calculated by the hand, we use the limit equilibrium method. It is easily calculated. But for finite element method or the finite difference method, we calculate it by computer, a software to calculate Homogeneous fine-grained soils can be observed to feel through a rotational mechanism. From this picture, we can know that this is a two-dimensional simple failure. The circular or non-circular failure surfaces and surfaces on a slice of soil. We should calculate or divide it into many slices to calculate. A is a circular failure surface and B is non-circular failure surface. When we decided or divided into some slices, there were different forces on one slice, just like this. There are so many forces. On each side, we have three forces. T for the bottom of the slide plane, we can have T, F, and NF. There are two forces. It is the shear stress and the normal stress. And on one other side is this, also the normal force and the shear force. But have so many parameters. Some of them we didn't know how to calculate it. So we should assume some parameters to simplify the calculation. If all parameters we concede, but in fact we can know how to calculate. So we should simplify these parameters. Some of them. We can know that Wg is the total weight of a slice including any external load. Ej is the inter-slice natural effective force. And another is the Tj is the mobilized shear force along the slice slip surface. And Xj is the inter-slice shear force. Another is water pressure. Is the N, the slice of the one side and another side. And the location, Jw is the location of inter-slice natural effective force and the pore water force. And another, we can know each of the parameters mean. Slope analysis method based on limit equilibrium. There were many methods, and a Swedish method, Bishop's simplified method. Bishop's method was string and points. Spencer, Bear's method in Jimbu and Summer. So there was so many different methods to calculate the slope stability. But for different methods, the assumption is different. The difference of the method is that with different assumption. We can know that Swedish method, we assume that the resultant of inter-slice force is 0. But for Bishop simplified method, it's EJ and EJ plus 1 are co-nonlinear and is equal. And G is 0. And the failure surface is circular. But for this method, the failure surface is any shape. But for Jimbo, it's non-circular. So it is assumed some parameters are different, failure surface are different. And equilibrium equations satisfied. One is moment. This Swedish Bishop's simplified Bishop's method is only consider movement equilibrium. But for Jimbo is horizontal force equilibrium. So there are assumption is different, failure surface, and the equilibrium equations satisfied are different. We should, according to different method, to determine according to actual conditions, to determine which method we used to calculate. Now we are talking about it's almost 10 past 12. We are talking about in later class. You copied PPT and spend some time to read it before class. Okay. Okay.
Bro, they are like 14 gig.